we're going to, this is, I guarantee you'll have to do on the test, which is 1 week from today. You have to find the zeros for this particular polynomial. Find the zeros and factor. F of x equals 2x cubed. If you don't have that little slip of paper that you were given yesterday, look on with the table partner. If you've completely lost it, I have some extras up there in the inbox. Okay, so what does it say at the very top, Lexi, of the sheet in italics? Factor if you can. This one's not factorable, but I'm going to quickly show one that would be factorable, and just a simple one. So let's say we had g of x was x squared minus 4x, this quadratic. So how many zeros do we anticipate, Taryn? Good. Why, Taryn? Good. There will be that number of zeros in the complex numbers, counting multiplicity. So it might be a double root situation. There's going to be that number of zeros. Okay. So this one's factorable. Who can tell me how we could factor this thing? What's the first thing we look for when factoring? Good. GCF. Greatest common factor. Does this one have a greatest common factor? What is it? 1x, Taryn says. Say it with some conviction. I don't know you to normally be quiet, but
Well, that's what I said earlier.
I'm sorry.
You said that was wrong.
I didn't say it was wrong. I don't think. Forgive me if I did. I was wrong. Forgive me. Factoring out x. What is x squared divided by x? Good. What is minus 4x divided by x? Good. Using the distributive property, x times x is x squared, x times minus 4 is minus 4x. Questions? All right, well, we want to find the zeros. Algebraically, we can just set y equal to 0. And now I'll set both of these factors equal to 0, setting both factors equal to 0. X equals 0, that's done. Setting x minus 4 or x minus 4 equals 0. Noah, I want to solve this one. What do I do? We did. Here I set x equal to 0. That one's done already. Or x minus 4 equal to 0. I want to solve for x here.
Add 4.
Good. Adding 4 to both sides. So we get x is 4. I want to key on this link here. The link between the 0, which is the x-intercept, also called the root, and the factor. If the 0 is x equal 4, the associated factor is x minus 4. That's very important to us. Any questions? All right, so if we can factor it, we don't have to jack with this 6-step process. But this one we cannot factor. Rashad, what's step 1 on our process? So we want to find candidates for the solutions of our original polynomial. Hopefully you remember the rational root theorem says take the factors of the constant, and divide by what? Good. What is a, Taryn?
The coefficient of the highest power.
Good. We say the coefficient of the leading term. Well done. In this context, what is the constant, Jaden? Good. What is A, Emily? A is 2. Very good. Is everybody okay with that? All right. A is 2 and C, or the constant is 6. So here I go. The factors of 6, anybody?
6, 1, 2, 3.
Good. 1, 2, 3, 6. There will be an even number of factors unless the number is a perfect square. A perfect square has an odd number of factors. Okay. The factors of 2 are, good. Well, if you divide all of these numbers by 1, it's just going to return those numbers. So we're going to have plus and minus, that same set, 1, 2, 3, and 6. But we also need to divide by what, Peter? Good. So what would 1 divided by 2 be? Very good. I'm just going to call that 1/2. Thank you, Peter. How about 2 divided by 2? But we've already accounted for 1, haven't we? Great. How about the next one? Very good. I'm just going to write that as 3/2. Great. Does everybody see 6 divided by 2? We've already accounted for. Okay. So these are our candidates. If there are some real zeros, rational zeros, they will be amongst this list. Are we guaranteed rational zeros for this cubic function? Yeah, we are. Because the odd functions, they increase to one side and decrease to the other. We're guaranteed at least one real root. At this time, everybody using Desmos or looking on with a table partner or something, graph this function. 2x cubed minus 5x minus 7x plus 6. I didn't change. I forgot to make the change there. This 7, forgive me. Emily, how'd you let me do that? It's Emily's fault. It's not Emily's fault. It's my fault. Change this 7 to a 1. Sorry. Forgive me, y'all. Looks something like that, doesn't it?
-1, 1.5, and 1. Yeah.
And 2. Is everybody with me? Okay. -1, 1.5, and 2. Those are the three zeros. And naturally they're on that list. Plus and minus, so that's -1. That's 1.5, and that's 2. Yeah, so Taryn's like, we can see them. Can't we be done there? If the goal was just to find the zeros, absolutely. But here you're going to have to demonstrate this process because we're acting as if we can't graph it. What we should do is take each one of these values and substitute them in and see which one actually presents a 0. But I don't want y'all putting all those numbers in there. So I'm allowing you to graph it to find 1 0. Okay? So we're going to select one of these numbers. We could select -1. I'm going to select 2. Okay, I'm going to select 2. Now, there's nothing wrong with -1. So step 2 says graph to find one real 0. Write its associated factor. So we have found the 0, x equal 2. What we are saying is f of 2 is 0. That's what I mean by 0. That's the same as saying 2 pairs with 0. We can see that point, 2 pairs with 0. Since x equal 2, what is the associated factor? Close. It is going to have a -2 in it, but we need... Good. Since the 0 is x equal 2, the factor is x minus 2. I could subtract 2 from both sides, and we would see x minus 2 goes with 0. Is everybody okay with that? All right. Jaden, what does step 3 say on the notes? Good. So we're going to use this 0, and we're going to perform synthetic division. We're pretending we don't know what all those roots are. For our synthetic division, we use the coefficients here. 2, -5, -1, and 6. Little separator line. And this process we bring down. Now what? Good. 2 times 2 is 4. Summing -5 and 4. -1. 2 times -1. Summing. What do we know is going to be right here? That's right, because this, we call it synthetic division. It's also called synthetic substitution. If we were to substitute 2 in place of x, we know it would produce a 0. If we do 2 here, we're going to get a 0 there. Okay. 2 times -3 is -6. Summing is 0. Questions? All right. Step 3. Write the original polynomial as a product of your step 2 and step 3 factors. Well, this we knew this was going to be a 0, but the key is this is the new polynomial when we divide. This 2 is really 2x squared. This minus 1 is minus 1x. This minus 3 is just minus 3. This thing times the step 2 factor, which is x minus 2, is our original function, our original f of x. I'm going to rewrite that just for the sake of showing. The original function was f of x equals, need an equal in there, 2x cubed minus 5x squared minus 7x plus 6. Questions? The blue line is where we are. Here we have divided this thing here is this. This x minus 2 is this. When we divide this by this, we get this thing here. Now, we have a simplified polynomial. Solve, find the zeros of that simplified polynomial. It will likely be a quadratic. We can see this thing is a quadratic. We are now going to set this equal to 0. We're trying to find the zeros. That's why we set it equal to 0. We've already set this one equal to 0. It's x equal 2. Now we're going to set this one equal to 0. Well, this one is factorable by the big X method. In a couple weeks, we're going to spend a lot of time practicing factoring. Yes? What did I screw up? Thank you. Thank you. That's that same error I made earlier. That's my original. I'm setting this thing equal to 0. I want to find the zeros associated with it. Yes, Rashad. Yeah, we could factor it big X method, but we're not going to. Okay? Yeah, I'm going to show the quadratic formula just because we need some quadratic formula practice and everything we can use the quadratic formula for. Okay? So the quadratic formula is good. X
b squared. This is where it's going to be. B squared minus 4ac all over 2a.
All right. I'm recording this for a good job for a video so y'all can look at it later on if you need to. Okay. All right, where a, b, and c are from the form ax squared plus bx plus c is equal to 0. So in our particular case, a would be what? Good. B would be no. Good. And C would be all right. Guys, when y'all are when doing the quadratic formula, find the discriminant first. Find this underneath thing. Because it gives you a lot of information and it'll clean up just the process here. I'm going to find b squared minus 4ac. So that becomes good. Negative 1 squared minus 4 times 2 and negative 3. As Taryn just said, negative 1 squared is 1. 4 times 2 is 8. Times 3 is 24. And 2 negatives make a positive, so it's plus 24. What is 1 plus 24? If this number is a perfect square, the polynomial is factorable. That's wonderful information. If this number is not a perfect square, it is not factorable. So if you have a trinomial and you're trying to decide, can I factor it? Just find a discriminant. If it's a perfect square, you can factor it. If it's not a perfect square, you're on your way to having done the quadratic formula. Okay? So here I go. I'm going to continue with my quadratic formula. X equals negative b. If b is negative 1, negative 1 is good. Plus and minus, square root of, well, we've already found our discriminant. It's 25. Do you see how this is cleaning up our quadratic formula? Very good. 2 times 2, this will be 4 here. Any questions? What's the square root of 25? So we have 1 plus n minus 5 over 4. This is two separate numbers.
4 and 6.
It's 1 plus 5 divided by 4, or, good. 1 plus 5 is 6, and 6 over 4 is 3 over 2, which we already knew. 1 minus 5 is negative 4. Negative 4 divided by 4 is a negative 1, which we also already knew. So we have our three zeros, 3 over 2, negative 1, and 2, which we knew from the graph. Negative 1, 3 over 2, and 2. Okay. It says use your zeros. Our zeros are x equal 2, x equal negative 1, and x equal 3 over 2. To write the polynomial in factored form. So f of x equal. If the 0 is x equal 2, what is the factor? Very good. If the 0 is x equal negative 1, what is the factor? Good. This one will be x minus 3 over 2. Any questions? We could further basically multiply by 2 here and write this as 2x minus 3. But there's nothing wrong with having it in that form. Those are our zeros. This is the factored form. What are your questions? I guarantee you'll have to do this on the test more than once. I would suggest taking that little sheet there and putting it on your index card. Thank y'all.